Good morning, guys. Today we are going to conclude module 4.4. Yes, it is an intense unit. And in this, we have already covered translations in my first video, dilations in my second video, and this is the final part of transformations, which is reflections. And a reflection is a transformation that flips a graph over a line of reflection. So I just want to refresh your memory from 6th grade where we had done reflection of a point over the coordinate plane. And we had talked about the reflection can be up or down, which is over the x-axis, and from side to side if it's over the y-axis, because this is x and this is y. So now let's look at this. Reflections in the x-axis, we are seeing the difference between the two. And you multiply the outputs by -1, changing their signs. And this is the equation for it. It says y is equal to -f of x. So what is happening in reflection of the x-axis? Let's say I do an ordered pair of 3, 2. So if I say 3, 2, which is here, and I'm just doing a quick review from 6th grade. So this is 3, 2. And I ask you to reflect it over the x-axis. Which one is the x-axis? So I'm just going to make it with a dotted line so you can see. This is my x-axis. So I am going to treat the x-axis like a mirror, and I've told you reflection is like a mirror image. To think of it, when you're standing in front of the mirror, your reflection is the same distance behind, right? So therefore it's the same thing here. So if we are reflecting over the x-axis, when it says y is equal to -f of x, that means my x, if it's reflecting over the x value stays the same, and the y coordinate becomes the opposite because I'm multiplying it by -1. So this is what it means. If I'm reflecting here, look, what is x? It is 3. So this stays the same, And what happens to the y? Look, I'm going to go here and I'm going to reflect the same distance here, and it said 3 and 2. So this is going to be 3 and -2. So when I'm saying this is what the reflection means. X stays the same and the sign of y becomes opposite. Sign of y is the opposite or the inverse. Okay? So look, when I'm reflecting over the x, it's 3, 2. Once again, 3, that is x has stayed the same and the y has reversed. And that's what this means, because we are multiplying the outputs by -1. Let's look on the left side now, and we talk about reflections in the y-axis. Now, y-axis, which one is the y-axis? This is the y-axis. So, same thing, if I have 3, 2, which I had plotted earlier, and this is again a quick refresher of what we did in 6th grade. So I'm just refreshing your memory. So now look what it's saying. Multiply the inputs by -1, changing their signs. And y is equal to f of -x. So when I am, reflecting on the y-axis, going from side to side, whichever axis I'm reflecting on, that point remains the same in the coordinate, pair, the ordered pair. So if I'm going across y stays the same, and x will become the opposite sign, okay? So in this case, if I have 3, 2, guess what? 2 is going to stay the same because that's my y. And what is the reverse of 3 is negative 3. So I am going to go here and here. So this is my reflection, and see what has happened. This has become negative 3 and 2. So when I am reflecting on the y-axis, and this is my y-axis, just showing you with a different dotted line, which is red in color. And so look what has happened over here. My y has stayed the same, and the sign of x is reversed. So sign of x is reversed, which will become negative. And y is the same. Y is the same. So this is a quick refresher of what we have done in the past, and now we are just applying it to 8th grade. Now, the only difference now is, like, we know how we have done the ordered pairs in 6th grade, but now all we're doing is we are graphing a linear function into this and then reflecting that. For example, I might do something like this. Okay, I might do something like this. Okay, and so I am going to look at what are my ordered pairs over here, and then I am going to reflect it on the x-axis. So if I look at the ordered pairs here, I have 3, 2, I have 0, negative 1, 0, positive 1, I have negative 2, 0. Okay, so what did I say is going to happen when I flip it over the x? I said x stays the same and y is going to be the opposite. So we plotted the first one, which is 3, negative 2. X is 0, y is 1. So the opposite of the y is going to be negative 1. Okay, so here is my point, which is 0, negative 1. And then if I'm going to look at this one, opposite of 0 is 0. So here is my next point. And look how my graph is going now. Let me show it with a different color. Okay, so here is my graph. There we go. And this is reflected on the x-axis, as you can see. All right, and so once again, this is just a reflection on the x-axis. Whatever you are doing to the ordered pair, please remember, if I'm reflecting on the x-axis, it has to go up and down. And so if it's on the x stays the same, and y, the value of the y coordinate flips. So x coordinate stays the same, value of y flips. Let's look at this one now. Again, this is going to become a line. So in this case, let's say I am drawing the same line over here, and I am just going to show this with it going this way. And we had, here's my line. Okay, and now where are we flipping it? We are flipping it on the, or reflecting it on the y-axis. So the y is now going to stay the same and x is going to become the opposite. So let's write out those ordered pairs. So this was going to be my 0, 1, and this was negative 2, 0. Right? So now let's look at the new this thing. So we already have negative 3, 2 over here, and I'm just going to do this with different color. So as you can see, x has changed, y is the same. Okay, and then while coming down, let's look at this. This is going to be, x is going to be 0, and so this stays. Okay, and then over here, opposite of negative 2 is 2, and that is 0. So here we go. And now let's look at my graph. So look, there's a reflection on the y-axis. But see how it looks the same on both sides? Over here it looks the same on both sides. And that's basically what a reflection on the x or the y-axis means. Okay, so let's go ahead, and I just want to show you the definition of what we just talked about, because now we are going to use the parent graph and the parent function where f of x is equal to x. And so I know if x is 1, y is 1. If x is 2, y is 2, etc. Okay? So same thing that I just said. The graph of negative f of x is the reflection of the graph of f of x is equal to x across the x-axis. So here is my graph of f of x, which is my parent function. Okay, and I am just going to reflect it across the x-axis, because as you can see that the negative f over here tells me that the output values are changing. The input is going to be the same, so that means x coordinate is not changing. The y coordinate is going to become the reverse, and that's what we just talked about, and so it's reflected across here. Okay, so every y coordinate of negative f of x is the corresponding y coordinate of f of x multiplied by negative 1, and we just talked about that. And then let's look at the other one where it's saying the graph of f of negative x. So now looking at that, I know that my y, which is going to stay the same, all right, and my input is what's going to change. So the ordered pair, x is going to become the reverse and y is going to stay the same. So it's going to go across the y-axis. So the graph of f of negative x is the reflection of the graph of f of x is equal to x across the y-axis. And again, this is my parent function. So the both graphs are going to look identical in this case, because it's the same thing whether you're reflecting up or down or going from side to side. But I just wanted to show you that this is the y and it is reflecting across that now. And every x coordinate of f of negative x is the corresponding x coordinate of f of x multiplied by negative 1. So just a quick refresher of what I just showed you on the board. So let's go ahead and solve some problems for this. So I've just gone ahead and I've started creating a table to save time, and it's talking about graphing g of x is equal to 1/2 of x is related. So once again, describe how the graph of g of x is equal to negative 1/2 of x is related to the graph of the parent function. So once again, parent function of a linear function, we have f of x is equal to x, and f of x is again, it's y is equal to x. So I have also gone ahead and graphed it. If x is 0, y is 0. If x is 1, y is 1. If x is 2, y is 2. If x is negative 1, y is negative 1, and so on. So I've gone ahead and graphed that linear function. And now let's go ahead and look at the value that has been provided to us. And we can say that the constant a in this case, it's not grouped with x. It's not grouped with x. So what does that mean? That means that, this is less than 1 also. This is also less than 1. Okay, so the graph of f of x is equal to x is going to be vertically compressed. It's going to be vertically compressed. All right, now the negative is not grouped with x, so the graph is also reflected across the x-axis, because as I've told you, it's in front of the, it got the negative 1/2, so of the f, because we said negative f of x, that means your x is going to remain the same and the y is going to flip, and that's basically what this is over here. So it already tells me that it is reflected across the x-axis. Okay, and also the graph of g of x is equal to negative 1/2 of x is the graph of the parent function, vertically compressed and reflected across the x-axis. So let's see what to do. So now we are going to go ahead and we are going to start solving it. And I am going to give some values because we have negative 1/2. And of course, it is a fraction because I'm going to try to find numbers which are compatible when I divide by 2, like 2, 4, 6, 8, etc. because then I can simplify the numerator by the denominator. So I am going to take values like -2, 0, 4, etc. Or you can choose 2, you can choose 4, 6. It doesn't matter, but those are the ones that I am choosing. Okay. Now we know that in the parent function, f of x is equal to x. So f of x is equal to x is equal to this. Okay. And now we are doing so it's saying negative 1/2 of x. So we are going to multiply negative 1/2 times -2. And as I can see, negative divided by multiplied with negative gives me positive, right? And then this and this are going to cancel out. I end up with a positive 1. So once again, when I'm multiplying two numbers with the same sign, in this case, the negative times negative is going to make it positive. Okay? And then, of course, 1/2 of anything times 0 is going to be 0. And then I have negative 1/2 times a positive. So I'm going to get a negative answer. And 4 divided by 2, this is going to give me 2. So -2. So here are my values now. So my g of x, which is my ordered pair, is going to be -2, 1. -2, 1, 0, 0, and I have 4, -2. Now, once I have this, I am going to go ahead and graph it. And so -2, 1. So here's -2 and here is 1. Okay, there we go. So this is my -2, 1. And I have 0, 0. Okay, and of course I have 4, -2. So I have 4, -2, which is here. And this is my 4, -2. And then when I extend the graph, there we go. Okay, so what do I notice? Just look at this. This is my f of x, and this is my g of x. G of x. Okay, so here, look at this thing now. All the way here and then here. All right, so this is definitely, once again, this is a compressed, it's vertically compressed, and it is reflected across the x-axis. So this is one of the examples I wanted to show you. Okay. So here's the next example where we are trying to reflect across the y-axis. Once again, remember, this is the y. If I'm reflecting across the y-axis, now my output is not changing, but my input is changing. That means my y-coordinate is going to stay the same, and my input, which is my x-coordinate, is going to be multiplied with -1. And so therefore, whatever my input is, it's going to be the reverse of that, or the inverse sign is going to show the reflection, and it's going to reflect from left to right. Okay, so describe how the graph of g of x is equal to, grouped together now, negative 3x is related to the graph of the parent function. So now you can see that we are working on the grouping over here, and that is what makes it a y reflection, y-axis reflection. And I have gone ahead and created the parent function graph where f of x is equal to x. So this is my f of x is equal to x graph. And then I'm creating a table, and I've taken my input, or x, as negative 1, 0, 3. And so now we know that because it's grouped, that's the operation that we are going to perform first. And so negative 3 times negative 1 over here, negative 3 times negative 1, because negative 3 times x, right, negative 1. Negative times negative is going to give me positive, and that gives me 3. And then I have negative 3 times 0. Anything times 0 is 0. Negative 3 times 1, which is what? Negative times a positive is going to give me negative, so it is negative 3. So f of negative 3x is 3, 0, negative 3. So now let's look at my ordered pairs that I have over here. And I have negative 1, 3. I have negative 1, 3. I have 0, 0. And I have 1, negative 3. 1, negative 3. Okay, so I'm going to go ahead and now graph this using a different color. Let me use this. And negative 1, 3 is here. This is my first one, negative 1, 3. Then I have 0, 0, which is here. Okay, this is 0, 0, the origin. And then I have 1, negative 3. So 1, negative 3. So I'm going to go ahead, connect. There's my graph. Okay, and this is my g of x graph. That the graph of f of x is equal to x is horizontally compressed, and the negative is not grouped with x. So the graph is also reflected across the y-axis. And the graph of g of x is equal to negative 3x is the graph of the parent function, horizontally compressed and reflected across the y-axis. Okay, so it is horizontally compressed and reflected across the y-axis. All right. Let's look at this really quick. And let's read this and what it is saying. And this is the last question for reflections. Okay. And okay. So it's saying, describe how the graph of g of x is equal to, remember the grouping, negative 10x is related to the graph of the parent function. The graph of g of x is equal to negative 10x is the graph of the parent function compressed horizontally. And what is this reflected across? It's going to be reflected across the y-axis. Reflected across the y-axis. All right, so, and that's basically the reflections, everything that we have done in 6th grade, but now all that we're doing is we are transforming it to a line and to a linear function. So just remember that if it is being reflected over the x-axis, my x coordinate stays the same and the y coordinate sign is reversed. If it is reflected across the y-axis, the y coordinate stays the same and the x coordinate sign is going to be reversed. Okay, so that basically concludes transformations. Remember, there are 3 different videos on this module. Module 4.4, yes, it's a big one. The first video is on translations. Once again, that is when your line is moving either up or down, or there's a shift left to right. Okay, and then we have dilations where we are compressing, stretching the graph, or shrinking the graph. All right, and that is your dilations. And then the last one that we completed today is reflections to linear. We are applying reflections to linear functions. And that concludes module 4.4. Have a fantastic day, everyone.